What is up, gang? Mr. B here, bringing another sweet, wicked, awesome math video. In this video, I'm going to take two graphs of absolute value functions, and I'm going to figure out the equation of the transformation. So we've already done lots of general functions, and occasionally you'll see these, very specific functions like absolute value, quadratics thrown in, where we sort of got to problem solve our way through using our knowledge of transformations. It's really the same thing. There's not a whole lot of difference. So you should be, if you're good at general functions, you'll probably be good with specific ones as well. You just got to kind of have a little bit of experience in dealing with them, and then you'll be able to deal with pretty much all of them. If this video helps, like, share, subscribe, and here we go. Boom! Into the screen. All right, guys, I hope everyone's having a great day today. We are rocking some math videos, and we are rocking hard because I'm doing lots of videos today. So we're given the equation, the graph of y is equal to the absolute value of f of x. So this is this guy, just a general absolute value linear graph. And it's transformed using the mapping rule through this one. And that's the equation. So essentially what we want to find is just like every other mapping rule question, a, b, h, and k. All right? So when we do that, though, what we notice here probably is that, we don't have specific points highlighted to us. So we have just a regular graph. So one of the first things obviously is to label, but we also want to label and identify the key points that we're going to use to be able to sort of judge how the transformation went. So on a regular quadratic, we have quadratic, absolute value, 0, 0, 1, 1, and then 2, 2. And then negative 1, 1, and then negative 2, 1. So that's sort of our base keep saying quadratic, I'm probably going to keep doing it, base absolute value table. So we want to see how those points were transformed via a mapping rule. So, there's a couple little caveats about this, is that we're not given those points. We have to guesstimate them as best as possible on the new graph, right? So this is the old graph. I should have done that too. Old graph and new graph. In general, your teacher may label those points. They may not. If they're not labeled, then we have to label them ourselves. And what I generally do is I just pick good points, the first ones that appear right there, just like that. So I pick the first 5 good points that appear on my graph. So that assumes, of course, that my a, b values and my h and k values are good numbers. If that's not true, then this method might fail a little bit. So we'll see how it goes, and we'll give this a shot. All right. So after we get this thing done, first thing we do is we look at the reflections. Now the thing about a absolute value graph, it is completely symmetric. So you can see that any reflection in the y-axis does not matter. It just flips, right? It flips over. It looks exactly the same, right? I can't really do it with my hand because my hand doesn't look exactly the same. It looks exactly the same no matter what you do. So really, this thing cannot have a reflection in the y-axis. But we do want to look and see if there's a reflection in the x-axis if it flips over this way. So I usually look to see if it opens up and opens down. So if this thing, the pointy part, is pointing down, then all of a sudden, bam, it's pointing up. So it must have flipped over the x-axis. So there's a reflection in the x-axis. And now the question remains, what does that mean? So that's where we go with our x by rule. So, and again, if you're not familiar with this, it's this first video that you've watched of mine on transformations. Essentially what the x by rule is a rule for reflection. And how I came up with it is that in Newfoundland we always say by a lot. Yes, by. What are you at, by? So ax by. So ax by. Ax by. It needs me ax by. And essentially this reflection rule allows us to tell the signs of a and b, and an easy way to do it. So if I have a reflection in the x-axis, it means that my a is negative. If I have a reflection in the y-axis, it means that my b is negative. So I have a reflection in the x-axis. It means my a value, a is negative. And that is huge. That is so important to remember, all right? That you need to be able to sort of sort out a way to figure out how to find the signs of A and B in these questions. And the signs come from the reflection, so you need to figure out a way to remember how does the x-axis and how does the y-axis reflection determine the signs of A and B. You need to remember that. So a reflection in the x changes A, the reflection in the y changes the sign of B. Negative and positive only, that's it, okay? All right, so once we got that done, then we want to look at the stretches. So HS and BS. So what I normally do for this is I make a little table, and this little table helps me organize my information and make sure I don't make any mistakes, which, you know, doesn't really help me, but, you know, it is what it is. And I always put the new and the old, new on top, old on bottom, and then X and Y. So I want to look at the new first in the X direction, so I'll go to these 2 points and compare them to these 2 points, right? So this one goes from -1 all the way to 3, so that's 4 units. This one goes from -2 all the way to 2, so that's 4 units as well, so 4/4. And then the new one goes from -3 all the way to, is that 7? Yep, so that's 4 units, -7. And then this old one goes from 0 to 2, so that's 2 units, so it'll be 4/2. And then we'll do our HS. So HS, horizontal stretch, goes with the x-axis. We want to see if it got shorter or longer in the x-axis, so 4/4 is just 1, which makes sense. This thing is not any wider than what it was. The VS is equal to 4/2, so new over old, and then we divide them. So yeah, I should have mentioned that we use the formula for our stretches. VS is new over old, and same thing for HS. HS is also new over old. So that's why I like the table. You just literally just divide them. You could make a third column on this table if you wanted to and call it the stretches. It really doesn't matter. Once we have those stretches done, then what we want to do is we want to really focus on finding the A and B value. So A and B. So for A is related to the vertical stretch. So our vertical stretch is equal to 2. So remember that the formula for the vertical stretch is vertical stretch equals the absolute value of A. So if A is 2, the vertical stretch is 2. But the thing that we need to remember is that this formula does not determine the sign. We have to determine the sign by looking at the reflections. That's why that's the second step that I did. There's a reflection in the x-axis, so that means that A is negative. So we know A is 2, but we need to know whether it's plus or if it's minus. So in this case, it is -2 because of that reflection. The horizontal stretch is 1. Normally, the horizontal stretch is reciprocated, HS over 1 over B. So 1 over B, or absolute value of B, means reciprocal. And there's no reflection in the y-axis. So we end up with B equals just 1. Well, the reciprocal of 1 is just 1, and that's pretty much it. So now what we can do is we can go ahead and find our H and K values. And there's a little cat meowing at the door there. I'm not letting it in. So what I normally do for H and K values is I pick a point on the graph and I see where that thing is transformed via the mapping rule. So what I need to do is I need to put this mapping rule together from what I already have. So I've got the A value and I've got the B value. So remember, my mapping rule is just xy goes to 1 over bx plus h, ay plus k. So I know my B value is 1, so it's just going to be 1x plus h. And then the y value, or sorry, the A value is -2, so it's going to be -2y plus k. Now the question is, how do we use this? So what we do is we pick a point. I'm going to pick 0, 0, because that seems like this is the easiest one to pick. Then I'm going to pick what that point turned into. That point turned into 1 and -3. So if I go ahead now, and I need to think about it, this 0 is going into the mapping rule and out pops 1. So I take this part of the mapping rule, x plus h, and I put 0 in. So this is finding h. So 0 plus h equals 1. So obviously the value of h then is just 1. And we get a little mini equation that we need to solve. So this one is going to be negative 2. I put 0 into the mapping, so negative 2 times 0 plus k equals negative 3. This cancels out, and then I get k equals negative 3. And there it is. Those are my h and k values. So from that, I can now write the equation. So just using this form that's given to us, so f prime of x, could also call it y if you wanted to, is a, which is negative 2, absolute value. B is 1, so we don't need to write it. And then it's x minus h, absolute value, minus 3. And there it is. There is our transformational form for the absolute value function. We could also write the rest of the mapping rule. Really, it all is just to add your h and the k to that. So it'll be xy goes to x plus 1, and then negative 2y minus 3. And then what I would suggest is, running through the rest of the points to see if they match. So you might try 1, 1, see what happens, and then keep going with it, right? So 1, 1, if we put it through, that'll give us 2, so that's 2 right there. And then if we put 1 in here, that gives us negative 5. So that's that point, right? So you can keep going, double check that all the points work out, and then you'll know you did it right. All right, guys, another sweet, wicked, awesome math video, as I like to say. Thanks for watching. If there's any questions, feel free to comment, or if you're one of my students, feel free to write, email, whatever. And thanks for watching, and I will see you guys in class. Peace!
Hey, I like this guy's mathematicals.